Okay, class. We're going to continue with reciprocal trig functions, but now we're actually going to answer a few types of questions that you would more likely see. So now that we understand reciprocal trig functions, we're going to answer the question if we can determine the exact value for each of the following. And remember, as soon as you see the word exact value, you know that you're going to look for those special triangles. So there's going to be those special values that come up, which are, if you recall, the triangles of pi root 6, pi root 3, 1, and 2, as well as the pi root 4 and pi root 4 triangle, which is 1, 1, root 2. Okay, so we're going to be using one of those types of angles or the multiples of those angles, okay? So when we think about cosecant 7 pi over 4, we always go back to our drawing of our Cartesian plane. And where does 7 pi over 4 happen? That is very close to 8 pi over 4, so we're almost at full rotation. So 7 pi over 4 is this angle here. And therefore, what's left over here, the relative acute angle, is pi over 4. Okay, and so therefore we know that the side lengths are 1, 1, root 2, and cosecant is the reciprocal of sine of 7 pi over 4. So it's the flipped version of sine 7 pi over 4. So we know that to answer the question of cosecant 7 pi over 4, we're going to be doing the flipped version of sine. So 1 over sine of 7 pi over 4. And that's going to be in this quadrant here. And we also think back to our CAST rule, C-A-S-T. And if we're dealing with a cosecant, which is the reciprocal of sine, in this quadrant here, cosine is positive, which means sine is going to be negative. So we know that this answer is going to be a negative value. And what is sine of 7 pi over 4? Or we can actually simplify that further to being negative 1 over sine of pi over 4. And that is going to be 1 over root 2. Flipped version would be root 2 over 1. And don't forget the negative. We can just write it as negative root 2. We don't need to put that as over 1. So we can say that cosecant of 7 pi over 4 is equal to negative root 2. And that's the answer for that question. Moving on, let's try another example. Secant of 5 pi over 6. Again, we are going to draw our Cartesian plane. See where 5 pi over 6 is. That is almost a full pi, so it's going to be here. And therefore, our relative acute angle is pi over 6. And we are in the quadrant of C-A-S-T, so S being sine, but we are talking about secant, which is really cos of 5 pi over 6. So therefore, we know that this is going to be negative. So we know this is going to be a negative cos of, only if we think about just the relative acute angle now, of pi over 6. And it's going to be the flipped version of it. So therefore, it'll be negative cos of pi over 6 would be root 3 over 2. Flipping that over would be 2 over root 3. But we don't want to leave our reciprocals at the bottom, our radicals at the bottom. So you end up multiplying by root 3. So negative 2 root 3 over 3 would be my answer for this. Okay, let's do a little bit more. Ooh, this one's a fun one. This one is cotangent. And then do you see the special symbol here? It's squared. So whatever answer we get, this really means that we're going to find out what cotangent of 2 pi over 3 is, and we're going to end up squaring that final answer. Okay, so let's figure out where on the Cartesian plane 2 pi over 3 is. That's not quite a full pi, so we're over here. That is our 2 pi over 3. So our relative acute angle is pi over 3. And we are in the CAS. So we're in the S quadrant, which means cotangent is the reciprocal tangent. So therefore, we are going to be in the negative realm of it. So pi over 3. But because of CAST rule, this is going to be negative. So what is tan of pi over 3? I should go back to my triangle here. If I go to my triangle, I see that pi over 3, tan is root 3 over 1. Flipping it would be 1 over root 3. So the answer would be 1 over root 3 with a negative. We don't like to leave the radicals in the bottom, so we'll multiply that by root 3 over 3 is our final answer. Okay, so that is cotangent. Oh, but that, I forgot. We have to square the final answer of that, right? We should always be putting that along the way so we don't forget. So that means we are actually not done. We're going to square this one. But because we're squaring it, I actually didn't even need to have changed the radical form. I could have stayed here, because what happens is that when you square root a radical, so square root the square root, square a square root, you end up eliminating that square root. So you end up with negative 1, which is squared, which is positive 1 now, over 3. So the answer is 1/3. Look at that. Okay, don't forget the squared as part of the question. So that's why we always try to bring along every part of the question. Okay, so now let's do a challenging question. We have to determine all the trig ratios in the interval between 0 and 2 pi, so just one rotation around the unit circle. Not sure why that's doing that. Okay, and it needs to have the value of negative 2 over root 3. So when we think about that value, so we know that we have to find all the ratios that have this answer. So negative 2 over root 3. This is going to have the primary trig ratios, right? So those could be sine and cos, or tan. But it can also have, when we say all trig ratios, it can also talk about the reciprocal ones as well. So we can be talking about cosecant, secant, or cotangent. All right, so we have to know what is this as a possible ratio. So if we go back to our special triangles and we copy that, we bring it down here. Where is that possible to have root 3? Well, that's not going to happen in the pi over 4 triangles. That's only going to happen with this value and this value. So we're either going to talk about an adjacent or an opposite, and we're going to talk about hypotenuse. So because we're always going to talk about adjacent, opposite with a hypotenuse, that means that also tan and cotangents are out. So we're looking for all the possible trig ratios that are sine, cos, cosecant, and secant that are going to give us this ratio. So let's look at the sine value. So where can we get this ratio of negative 2 over root 3 to happen? Well, in sine, we know that the value is going to end up being a negative value, right? So where does sine happen to be negative in our Cartesian plane? Just in one full rotation, right? So that happens either in the tangent quadrant or the T quadrant or the C, which is the third and fourth. So that means that our terminal arm could be here or here, and that's going to go this angle or this angle. Okay, where can that happen? Well, in order for sine to happen, we're talking about opposites. So that means when we're dealing with opposite, we're talking about this as being our theta. So that means pi over 3 is our theta. We're dealing with the opposite over the hypotenuse. So root 3 over 2. So sine of pi over 3, we know is going to be root 3 over 2. But that's not exactly what we want. We actually want our reciprocal. So that means we're talking about cosecant. But that's not even the right angle. The angle we're talking about is the full rotation. We're just, this value here, or this angle here, is just a relative acute angle. So we are actually going to do root 3 over 2, pi over 3 over here as a relative acute angle, and pi over 3 over here. So then our first theta is a full pi plus pi over 3. So that really means our first angle is going to be 4 pi over 3, because a full pi would be 3 pi over 3. So therefore, one more would be 4 pi over 3. So there's one angle. And the second angle here is going to be just shy of a full 2 pi, so 2 pi minus pi over 3. So that would have been 6 pi over 3. So we're actually at 5 pi over 3. But again, it's not sine because our ratio that we wanted is actually 2 over root 3, which is the reciprocal. We actually want the reciprocal of it. So that means we want cosecant of 4 pi over 3 or cosecant of 5 pi over 3 would give us this ratio. All right? So we've taken care of it if we were looking at it from the sine perspective. But we could also be looking at it from the cos perspective, right? So the cos can happen when we're talking about adjacent over hypotenuse. So if we look at the cosine possibility, we're going to do the same thing, draw a grid, and where are we going to find the cosine to be negative, right? It's still a negative ratio, and that happens for us at the S and the T. So that's going to mean that our drawing is going to be our terminal arms over here in quadrant 2 and quadrant 3. So our theta is going here, and our second theta is going all the way there. And our relative acute angle is going to deal with root 3 as an adjacent. So that means we're doing pi over 6 and then over 2. So cos of pi over 6 will give us the ratio of root 3 over 2. And again, we're going to deal with the reciprocal. But let's figure out our initial angles here. So theta 1 is equal to, if this is going to be pi over 6, we're shy of full pi, so pi minus pi over 6, which is therefore, a full pi would be 6 pi over 6, so therefore we're at 5 pi over 6. Our second angle is over the pi, so it's going to be pi plus pi over 6, so that's going to be 7 pi over 6. So that means that for the cosine value, again, we're not wanting root 3 over 2. We want 2 over root 3. So that means we're really looking for the secant version, or the reciprocal of this, at 5 pi over 6 and secant version of 7 pi over 6. So these are our 4 answers of all the trig ratios between one rotation that has this ratio of -2 over root 3. All right, good luck.